Today we're going to talk about the basics of local area networking. You should already have a basic understanding of how binary works and how we convert binary into decimal form. So please review that before progressing into this lesson. At this point, you should all have heard the term IP addresses in a sentence pertaining to networking. A LAN is nothing more than a bunch of devices talking on the same network that can be linked to other local area networks. In order to understand a local area network, we have to understand the basic principles that a network provides, which is IP addresses. IP stands for Internet Protocol. These are the rules and procedures of sending data across the network. And addresses are nothing more than a set of binary numbers for computers to understand. The typical address would be something like 192.168.72. These are numbers that help identify all devices that are in your network, which helps us to communicate with other computers on the network. The actual version of these addresses are called IPv4. To better understand how and why all this works, we need to go back to the past where it all started. Back in the 70s and 80s, ARPA was the first institution to install a network that spread across the United States. Soon, national, state, and local institutions had their own local area networks where these giant computers could be accessed remotely. This was the first packet transmission-oriented network. It is the basis of what we use today, whether it is on external networks such as the internet or internal networks such as a home or a business. Sure, there has been many advancements since then, such as hardware and software, but the fundamentals on how we address the network have stayed the same over the years. From a host computer, you could send data across telephone lines from Los Angeles to New York through an analog signal for the first time ever. Soon there was all these different networks popping up all over the place with the ability to send and retrieve data across the nation. At that time, the internet was not set up for commercial use, but used more like a utility for the government and institutions such as universities. In fact, personal computer and modems were more like an idea than it was a reality for most of the home users. They were expensive and cost thousands of dollars. In fact, in 1980, the top model passed for $3,000, which in modern times would equate to almost $10,000. The first graphical interface had just been invented as well, and no one even knew what a mouse was. In America, people had just got used to having 2 TVs per household. They recorded their favorite TV shows on VHS cassettes while nuking their favorite TV dinners in a new machine called a microwave. There was a lot of innovation back then, but the household computers was not quite there yet. The government and ARPANET thought maybe one day there might be 10 to 20,000 computers on this information highway. They never thought in their wildest dreams they would surpass the numbers of users that we have on the internet today. They thought at the time they were future-proofing any conceivable notion that the internet would hold over billions of addresses at one time. Boy, were they ever wrong about that. These public IP addresses are actually about to run out, and the need for larger set of addresses will have to be implemented to keep up with the demand. Soon we will have more computers and networks than IPv4 can handle. IPv4 has over 4 billion addresses. Part of the problem is that you can only use them once. No 2 computers can have the same address on any given network. Other problems stem from limitations to the addresses themselves. When IPv4 was implemented, certain numbers were reserved for designated functions and experimental purposes and couldn't be used. Others were bound by rules to make networking possible, such as no numbers that start with 255 could be used. So little by little, all these addresses were pared down and used up. In this context, when I say public address, I actually mean classical network address. There is this global institution called the IANA, which stands for the Internet Assigned Authority. They are the key holders to the Internet's public IP address. In other words, they have all the addresses that we need for public addresses on the Internet. These addresses are used to identify every user, whether it is at home, or an office, or on a server somewhere on the cloud. All IP addresses that are used around the world come from the IANA. They in turn hand out the ranges of addresses over to your internet provider, who in turn give you your public IP address. Normally, a single household only gets one public address. We'll talk more on how multiple devices can traverse the internet with a single IP address in another lesson. But for now, that one IP address per household is typically more than enough for any one user. This is just a side note. Your provider, such as Comcast, is not the internet. Let's think of the internet as a highway for a moment. Comcast only gives you a street address to access the lanes of other street addresses that already exist on the internet. Putting that aside for a moment, there are specific reasons we must distinguish the classes of addresses we use in a network. Today we're only going to worry about the first three. You have Class A, B, and C. These are the ones that are used the most. Alright, let's talk about these addresses. Every address with IPv4 has 4 sections to the address, separated by 3 dots. Each class of address has a fixed number within a section that can never change. These numbers can range from 0 to 254. Depending on where we fix this address dictates where we can change the second set of numbers. The last set of numbers in the address can be left up to the one that is handing out the address. As an example, for the Class A address, the first 3 numbers before the first dot is fixed, the 191. Once it is handed out, that number can never be changed, but the last 3 sections behind each dot is left with the ability to change the numbers up to 254. With a Class B, the first half of the IP address is fixed and cannot change, leaving the 2 sections behind the center dot with the ability to change its numbers up to 254 and behind each dot. And of course, Class C is where all the numbers before the last dot are fixed, with the last 3 numbers behind the dot can be changed all the way up to 254. Usually, by the time you sign up to your internet provider, they have typically given you a Class A address that they themselves have adjusted already. Just like a local area network, you are giving a single IP address. We will go more into detail how these numbers work, but CompTIA will expect you to know what a classful address is and what types there are. So now you're probably wondering how IP addresses actually work within a network. In order to do that, we have to talk about the purpose of an IP address. An IP address actually has 2 purposes. The first purpose is to identify the network. The second purpose is to identify what hosts are on that network. At home, you are a host of 1. The internet is actually a collection of those types of networks, and the principle is still the same. Your provider may have other homes in your area that are also hosts of 1. This would make your home and the surrounding homes almost like part of a local area network. Remember how I just said that with classful addresses, the first set of numbers of an IP address stays the same and the last set of numbers can change? That's because this is how we figure out the network address and the host address. A network address allows host devices to communicate within the group of devices. Without a network address, devices couldn't communicate with each other without the internet. or be protected from the outside world of intrusions. Host devices can be connected and transfer information from within their own community. Classful licenses allow organizations the ability to create a location to communicate on the web while having the ability to communicate with each other on their own private network. Depending on the size of the organization, a company can buy a license with a range of addresses that would create a public address and then support an infrastructure of multiple local area networks. A Class A license can have over 16 million hosts to one network. A Class B can have over 65,000 hosts on a network. And a Class C can only have 254 hosts on a local area network. The more numbers you use for the network address, the less hosts you will have for the network. Now to review, a LAN is a group of devices on a single network. IP addresses are used to connect these devices to other networks. IPv4 is the standard protocol for local area networks at the moment. There are over 4 billion addresses with IPv4. Most public addresses use the classful addresses A, B, and C. These classes are dependent on what size network you're going to have. And depending on where your network addresses ends and where your host addresses begins, it will tell you how many hosts your network can have. Thank you for watching this lesson, and we will go into more detail about classful addressing as we progress.